Hello everyone, welcome to DSA Carnival 2021. My name is Ansas Deva and I will be your host for today's session. Our speaker for today's session is Mr. Rahul Lather. He is a 6-star coder at CodeChef and Expert at Codeforces and currently working in Coding Ninjas. Today he will teach you tries. Also at the end of the session there will be a quiz and the first person to secure 100% marks in that quiz will get a t-shirt from Prep Bytes. Link of that quiz will be shared at the end of the session in chat box as well as the description box. Over to you Rahul sir.
Hello, Ansh. Hello, everyone. So, a very good evening to everyone. I hope I'm clearly audible. So, if anyone can tell over the chat, if I'm audible or not, and then we can start the session. Hello, Harshil. Hello, Satish. Good evening. Hello, Sakib. Hello, Harshil. Okay. So, I think we can wait 1 or 2 more minutes so that if anyone is still yet to join. Until then, can you guys tell me that, like, have you guys ever studied tries, have practiced some problems in tries, or are you complete beginner? So that we can discuss things accordingly. I'm just looking over chat on my laptop. Okay, can you guys please tell me, like, what? Okay, so complete beginner. Okay, beginner. Okay, seems like most of you are beginner. And do you guys like have basic knowledge of trees and recursion as we have already discussed in previous sessions? So that would be great if you have a basic idea of tries, like so not tries, trees. And okay, okay, yes. Okay, so I think let me share my screen. So is my screen visible to all of you? Okay, great. So, okay, I think we can start now. Okay, so today's topic we have for our discussion is tries, also known as prefix tree, and it is a very excellent data structure for strings. Mostly in most of the problems we will having using tries. And okay, so let's just directly. I first of all, I let me give you some overview of the session that some so like the first tries, and like as try is you as I have told you trees, so it has a structure that we will be discussing and some methods that we will be implementing in code, and we will be comparing it with hash maps, and in last we will also be discussing one problem where try is actually used in competitive programming as well, and some resources so that you can proceed further your learnings, and you can also practice problems. So, and okay, let's start. Okay, so like first of all, before jumping into tries, I will be discussing few things before so that you can have those idea around those state. Okay. So the very first point is prefix. Do you guys have any idea about prefixes? What is a prefix? Obviously, I have mentioned it over here, but do you guys know what a prefix is? Anyone, if have any idea, they can tell, or then I will describe what a prefix is. Anyone who can tell what a prefix is? Okay, we are starting with, yeah. Okay, so prefix basically is like a substring of a given string that basically starts with the very first index, that is zeroth index, and it the end index could be anything. Okay, so if we discuss it over an example, just a second. Yeah, so let me share. Okay, so let's say if we are given a string A, B, C, D, then so the length of the given string will be 4, right? And if we have to write all the prefixes of the given string, then what could be the possible substrings or prefixes of the given string? Anyone who can tell? So if we have to write prefixes of a given string that is A, B, C, D of length 4, so anyone who can tell me like prefix, what are all the possible prefixes of the given string? Yeah, correct. Murad Ablak have answered A, AB, ABC. Yeah, okay. So the prefixes would be like A, AB, ABC, and even at some points, if according to our definition, maybe we can consider ABCD as an prefix also, or maybe we can exclude it. That depends on our need. Okay. So yeah, that is general idea around prefixes, and why I have discussed it because tries have another name prefix trees. So that's why we should well aware about prefix and its definition. And then next point we will be discussing to discuss why try, why we need tries. So let's just come to implement a problem, a very famous interview question as well. So the problem is we need to implement a data structure that is dictionary. Okay. So we need to implement a word dictionary. And for now, let's just stick to only these two functionalities, add word and search word. So let's say if we need to implement a data structure that will store some words into it, and we need to implement these two methods, add word and search word. So in all the previous data structures that we have read, or you guys have read, arrays, strings, maps, trees, stack views. So what you can think like which data structure we can use to basically add words and search word efficiently, and like what time complexity we can achieve with both of these operations. Anyone who can tell like which data structure would be a good fit for this? The problem is clear, right? If anyone have any doubt regarding anywhere, then he can ask. K. Vishwajit has answered hash map. Anyone other? If you can, if you think there could be anything else other than hash map, then even you can tell. Okay, and okay. So can you also tell me time complexity for both of these methods to add a word into hash map and to add a and to search a word into hash map? Okay, so let's just discuss. Okay, so let's say we will be adding. We need to add a string basically, as we have already mentioned, A, B, C, D into our hash map. So if you guys have read hash map, so what hash map do is it will always calculate a hash for the given key, and then it will store it into the data structure, right? So to calculate the hash of the given key, it will definitely be traversing throughout the complete word to each character, and then it will calculate the hash accordingly with some formula and an integer, and then it will store. So if you guys see, either hash map, either we are adding into a hash map or we are searching into a hash map, the hash map will be always traversing throughout the string, right? So the time complexity, what do you think the time complexity for these operations would be? Rahul has set order of one. So yeah. So if, let's say, there are n words into our dictionary that we need to insert, and the average length, or you can say maximum length of each word is L. Okay. So we need if we do not consider the word length, then definitely it will be order of one, because the time is independent of the count of words that we are having, right? And it is, but it still depends on the length of word. So if we say the time complexity for insertion or searching or even removal would be always order of L, because it will be traversing each character in the given word, and that's why the complexity will be order of L. Okay. So do you guys have, if you guys have any doubt regarding whatever we are discussing, you can always put it in the chat and reading it. Okay. So the time complexity will be order of n for that operation. Okay. Now if we discuss, like, let's say in our dictionary, we need to search some method. We need to add some method that is starts with and the given prefix. So what this method should do is, let's say we are given some word, we need to find whether there exists any word in the dictionary that starts with the given prefix, right? And so let me write here. So let's say our dictionary have these words A, B, C, D, and whatever we can consider A, B, C, or B, F, anything. So these are the three words that we are having into our dictionary, right? Now we need to tell whether there is any word that starts with AB. Okay, and we have implemented those methods and implemented our data structures using hash map, right? So what complexity or in what order of time we can achieve this, like in how much time we can find out whether there is an word that starts with this prefix, that is AB, or any word, it could be any word that's using prefix. So what do you think the time we required, we will be implementing this method? So anyone, you can tell. Yeah, Rahul, that's correct. For string type, if we consider the length of the words, then it will definitely be not order of one. Okay, Vishwajit, tell its order of L. So I don't like, we can't implement or we can't find a word that will start with this prefix in order of L time, because see, if in a hash map, we should always search every key that we are having in our hash map to find and then compare with this prefix whether it is a start of that word or not. Otherwise there is like no such method provided by hash map where we can find directly in order of L that, okay, tell me all the words that are starting with A, tell me all the words starting with A, B, right? So the only possibility there would be to find all the keys in the hash map that are our words, and then comparing all the words with those with the given prefix, right? So the time complexity, let's just discuss it with. Okay, so as we have mentioned, we are having three words in our dictionary, right? And we are searching AB. So what we will do is we will start iterating on all the words or keys. So for the first key, that is A, B, C, D, we will search, we will compare by traversing that whether A, B is like a prefix of it or no. Okay, and we can identify it. Yes, it is. So we can directly return from here, right? That there is a word that is starting with prefix. But let's say if the first two words were not there in the dictionary, and there are thousands of other words that are starting with B, C, D, or any alphabet, but there is no word that is starting with AB, right? In that case, we will always be traversing through all those words, right? And then if we have not found, even we will compare the prefix and that word, each word. So we will also be considering the length of those words as well. Okay. So if we see the time complexity will definitely be n cross L for only this method, as we are traversing over all words and then comparing their lengths, then comparing them for their lengths, right? So did you guys get this idea that it is a very complex operation, that is order of n cross L? We definitely need to optimize it with other possible data structures. So any doubts here, or any, if anyone can also suggest any other data structure that we can use to also implement this operation efficiently? Anyone? Okay. So yeah, we definitely need to find an alternative that can achieve this functionality in order of L, that is length of word S. Okay. So for that, okay. So before starting that, let's just discuss on, let's say, as we will be searching some prefix in real dictionary, right? So how you start searching a word? Can anyone tell me like the word, first thing you do to search a word in a real dictionary? But like how we start proceeding to search a word, any word that could be present in a dictionary or even maybe not present. Okay, isn't like it something like we like look for the very first character that we are searching, and then we will look out the very first page where the word starting from that characters are, and then let me present my screen. Okay, so let's say we are searching a word, uh, ram, a very common word. So in while searching this word in a dictionary, what we will first do is we will just look for the very first character, that is R. Okay, and then we will find the page where the words from R starts. Yeah, Rohan said right, like we will go character wise. Yeah, okay, it's the first letter, right? So yeah, as I think you all have idea, so we will be searching character wise character. Okay, then like searching for A, all those words that are starting with RA, then RAM. If we have found a word RM, then we can definitely say there exists a word, right? So even in real life, as we are only doing order of n l work, so we should also like think of some data structure that could do the functionality in same time, right? So that's why we will be having tries for this. And let's just discuss first tries, and then you guys can relate that it will be doing the same work like as we are doing in the real dictionary, right? So tries is nothing but similar to tree structure, and it is like it will basically store the collection of words, right? It is also called prefix trees. Let's just directly see the diagram. So if you guys can see, we have try here some words in a try. So let me first explain what are these terms here. So basically we have start that represents the root of the try, right? Similar to a tree. So start will represent the root of the try, and each node basically start will have some children that are represented by some characters, right? So each node will have some information regarding their children and the character that they are like storing. And similarly for each node, they further have children. So in this way, we have an tree kind of structure here. And to store word, let's say as I have mentioned here, we will be inserting a here. Okay, so start will basically have a child corresponding to a to store word a. And if we need to insert dot, dot is a word, right? So when we are inserting dot into our try, so we will first tell root to basically it has to store dot word, right? Then first it will insert d here as its child, then d further have its child as o, and then o further have its child as t, right? In this way there are other words like new, news, not as well, gen. So all these words can be stored in a try, and the structure will look something like this. So if you have some idea around trees, then you guys must know like how it will be storing, and we will also be discussing it with a tree node structure. So do you guys got like the representation of a try, how it will be storing words, the character information it is storing here? Okay, so yeah, in this way we will be storing our words in a try, right? And now let's just see how actually in. Okay, so before jumping into like actual implementation and discussing if anyone can the depth each the try can have. Anyone you can tell me. uh, okay, okay, Pankaj is asking question, yeah. Okay, so question is basically, as we are having try, okay, and we need to tell the whatever what is the maximum number of children each node can have. That is the first question. And second question is, what is the maximum depth of the try? Length of longest word. So The length of longest word would be what? The maximum children or maximum depth? Yeah. Okay. So Pankaj and Vishwajit has said, yeah, absolutely. Okay. So definitely okay. So if we are using only capital alphabet to store words, so then we will be having only 26 characters, possible characters. So each node can have only 26 child, right? And if you can see this representation, so even the depth can only go to the length of maximum word here, right? So similarly here in the given diagram, you can see news is a word, NEWS. So that is having a maximum depth of 4. So there is no word that is more than its length. So definitely here the depth will be 4. And yeah, so and in worst case the children can exist till 26, right? So yeah, okay. And okay, so we have discussed we will be having 26 children at max, and now we need to analyze it. Let me okay, so like one thing we still we need to discuss here is let's we draw the or just a second. Uh, yeah, I think we have already that image. Okay. So one thing that okay, let's say we have this try, right? And now we need to find whether A R E, that is R, exists in our try or not. So what we will be doing is we will telling start, that is our root node, to search for ARE, right? And what so the root node will look for a node that is A, whether it has a child that contains A or not. So definitely it will have a child that stores A, right? Then basically we will tell A to find whether you contain a word RE, right? So definitely if A will look for R, whether A has a child that contains R, right? So it will say yes, I have a child, and then so we will say R to look for a node that starts with E, that contains E. So even R says that okay, I have a node that is E, and then the string becomes empty, so we can return from here. We can return true. Okay, so it means we have found a word into our dictionary that is ARV. But but if we need to say, let's say we have only inserted R into our dictionary, but we have not inserted ARE as a word, right? So, and if we search ARE, if we search for ARE as a word, so in that case, okay, so if we are searching for a word ARE, so what we'll do again here is we will ask root to find a word AR. Okay, it will check for A, then A will check for R. Okay, then the string becomes empty, right? At R will say that I have found, and string has become empty to search. So what we will do here is, will we return true? Because if we return true, then okay, okay, I think I missed something else. So what I was discussing is we are given this image. So now, as I told you, we have already identified we will be having 26 children, and already identified the depth. Now we need some more information around it. what other things we could require in a node. So like if we have to insert a word are, so let's just assume for now we are having only r as a word in our dictionary, right? And if we have to search this word, we can simply search like start will have a node, child node as a has a child node as r has a child node as e. We can say r exists as a word, right? Do you guys have any doubt regarding how we will search a word? Okay. Anyone? Any doubt regarding anything? Okay, so now we can search R as a word, but and we have only one word into our try. Let's just assume we have only one word, that is ARE. Okay. And now if we have to search AR as whether it exists as a word or not, then what we will do? So this is the word ARE, and yeah. So and now if we need to search AR as a word, whether it exists or not. So if we try, yeah, Rahul asked how we will search if do is a word. Okay, right. Yeah, coming to the same point, like if R is a word inserted in our try and we will search R, that definitely we have found it. But what if we have not inserted AR, but we still searching for AR, then what will we get? So root will search for A, then A will search for R, and we have found it, right? We have found AR as a word, but we have not inserted it. It is only a prefix of some other word. So in that case, we should return false, right? So do you guys think like for with each node we should have some information regarding whether that node is the end character of some word or not, right? So here ARE is an end character, sorry, end character. So definitely we need to have some information for this E that it is the end of a word. So that's why if also you are seeing this picture, all these black nodes are end nodes that of the words that we have inserted in our try, right? And the orange nodes are not end words or end characters. So yeah, so to represent this information, we will using a boolean variable with each node. This will tell whether like the node is an end character or not. So all these black nodes that you are seeing in the picture will be having this property boolean is end. Let's just name is as is end. So it will be true for all those black nodes, and for orange nodes it will be false, right? So now we have discussed that there are two things that require for a node. That is a boolean property to denote whether it is an AND node or not, right? And an array of nodes. Just like binary trees, we have two other properties left and right. Here we will have an array of, we will name it as children. So this will store all those children into it, right? So will be something that represents the structure of a node. So if you guys have any idea or sorry doubt here, you can ask. So here, if you can see in this picture, is each node is containing some information that is true and false, and an array that is like the A, B, C, D representation, and then so if the root node have child regarding corresponding to A, then A will have some information in that position. If Z is a child, then in the Z index we will having some information. So we can keep an hash map as well here instead of the array children, where we can directly map the indexes to the character, right? So any confusion, or if you have any doubt, then we can proceed further. If you have any doubt here, then we can start. Okay, I think. Okay, so Rahul has a doubt like why is there an array in each node? Okay, so see, yeah. So I have zoomed here the image. So if we see each node as a like there is an array and there is a boolean property, right? So each the purpose of array is if you have like wait, just a second. So in a binary tree, what we do here. Yeah. So if you have seen binary trees that looks something similar to this, right? So what a property, what properties a binary tree holds? As binary tree also holds some variables with left and right as well, right? So left, what left store is whether the do you guys are seeing the diagram? We Vinay asked instead of array can we keep a pointer and comment them as if a linked list. Okay, so instead of an array can we keep a pointer and connect them, connect them as if a linked list. Yeah, yes, Vinay, we can like store in any way all those childrens. Even in a map we can store, in an array we can store. So whatever works for us. So I think there's some issues with network. Am I audible? Just guys, please confirm whether I'm still audible or not, so that I can check before proceeding. Anyone who can just confirm. Okay, just a second. Yeah. Okay. So now it is visible. Okay. So as in, on binary tree, we have this information that left and right. For a try, we are having 26. We need to store those 26 children. So we will be having an array to store them. Imagine it like the first node in a binary tree. We are having only array of two. So will store the left, and this will store the right for a binary tree. Still two size array, right? Okay. So that's why we need to store like in the given picture. So for the node is having some child that contains A. There is no child that contains B, so that's why B is a null and C is a null also. So D has contains some value here. It means the given node has a child that starts with D and similarly Z. Okay, so that's why I think this answers your question. Why is there an array in each node? So it's like storing the information for each child, right? Similar to binary. So if we see the implementation for each of those methods, let me just first mute my camera so that there are no issues regarding internet. So did it clears your doubt? Rahul had this doubt. So if you can confirm it, we can discuss further. I think okay. Hello, am I audible? Anyone who can confirm? I think I okay, guys. So I think there was some issues with my network. Sorry, I was not getting your responses. Okay, so I think we can proceed with the problem. Okay, so we are discussing how we will be implementing add and search method here, right? And just to check, yeah. Okay, so to basically to implement add method, what we need to do here is, so first we will need to have a root to basically store our complete tree, right? Let's in our case it is a start, and to add any string or word, let's say we need to add at, that is in our try or a dictionary, right? So what we will be doing here is, okay, so now we are having a start node, that is our root, and we need to insert some word, let's say at, in our try, right? Okay, so the very first thing we need to do is, the start will look for a child, whether it has a child for corresponding to A. If it does not have, it will initialize it. Okay, and then call for this node to insert t into it, right? And this again will look for whether it contains a child with t, then it will, if not, it will initialize and insert. Now when the string becomes empty, so it means we have inserted the complete word, and we also need to mark the is and property to true. Let me just represent it with dark circle. So in this way, we are inserting word into try. So if you see, if we implement this using recursion, so for each recursion call, what we need is a node from where we need to inserting that word, the given word, right? And to insert it, let me just clear it first. And now if we see, to basically implement this add method, what we need to do, so this will be our method that we are given a node, we need to insert a word. Okay, so the very first step will be, it will be finding, we will later implement the base case. So it will first check whether there is any child corresponding to the very first character in the word. So we will first find the character in our word. Okay, and if we subtract this to, basically in this way we can find the index of that word. Let me just implement it. Yeah, so I have already implemented this method, so let me just quickly explain you. So to add a word into our try, so first we are having a root for our class. This is a try node structure that we will have, and to add a word into try node, we will be just skip base case for now, as we are finding the index for the character, zeroth character, and for the given node into its children, we are finding whether we are finding the child there at that index, right? So if there is a null there, it means we need to insert that, as we have discussed with the diagram. So it was clearly visible. So just in case if you still are not seeing it clearly, I will be definitely sharing this code so that you can check. So the child, if the child found was null, so we will be creating a new reference for it and updating our child, right? And the only thing, the best thing about recursion is we pass the sub problem to it, right? So we will pass the child to it and the remaining word, that is the word dot substring one. So the word starting after zeroth index, so we will tell child to insert that word, right? And whenever the base case would be the word, if the word becomes empty, we will simply tell this property to make it true and then return, directly return from it, right? So in this way we can implement add method into our try. See that this is just a small code, right? And the problems it can solve even in interviews are like really well. And this also, the try structure is very small, and this is an add method. If you guys will see search method, it is also very similar. I will like leave it as an assignment for you to like implement search method. There are not much changes. If anyone can tell me like what things we need to change while implementing the search method, can anyone tell me? If anyone can tell. Okay. Okay, so search was also similar to add method. just in this case search. Okay, so for a search, sorry guys, I just so for search method, we only need the base case will change similar to this. We just need to return the boolean variable we have stored. So if that is a true, then the word length becomes zero. So we will return true because we have found the word, otherwise false, right? And while considering the child, if each node does not have any child, we simply need to return false from there, right? So if we discuss it from here, like let's say we are having the word add into our try, right? And if we are searching a word that starts with B, so the start will basically start from B to look, and it will find that there is no node that contains B into its child, right? So it will directly return false from here. So it means we do not need to go further, and we can directly return false from here because we have not found anything, right? Any word starting with B or B. So in this way, we can implement the add method, search method, right? And remove method could also be implemented in a very similar code. And similarly, for starts with prefix, we, we will be just checking is node. When the string becomes empty, I let me just quickly show you the code. So if the string becomes empty, we can return true there, right? And if we are only considering the end nodes, so here we only need to change one thing. So this line, if the word has found, so starts with. So if we have come till now, this point, and the string becomes empty, we have found every node. So right, we will be returning true from here. So if you see, all these codes will run in order of word length, right? So in this way, we can also like implement remove and starts with. I will suggest recommend you guys to definitely implement these method. Otherwise, like if you do not implement them on your own, you will get like nothing like how actually they are implemented and helpful in solving problems, right? So, like, are you guys having any doubt till now? Anyone who have any doubt? Okay, so we can proceed. So just to discuss difference that we have started between hash map and tries. Okay, so Rahul asked what are the complexities for tries. See, so as we have discussed, like we are only traversing till depth of a try in any case. Even when we are adding, we are only traversing the given word. That is, let's say we are adding at, so we are only traversing A and T. Even if we search at, we will traverse only A and T. And similar for removing and starts searching with prefix. So in all those methods, we will only be traversing to the given word, right? So the complexities will be order of length of word only. Okay. So is this clears your doubt, Rahul? Yeah. Okay. So now coming to the like difference between hash map and price. So first, If you compare the order, then method, okay. But if we see like the performance wise also, the tries are faster. And even in space, if I could give an example that is already mentioned here, let's say we are inserting these words a starting with a, these 26 words that starts with a and a b a c into an hash map. So there will be 26 word into our hash map, and each containing two characters, right? So 26 words and two characters. So it will total contains 52 chars. But for a try note, we are having a only once, and then there are having further child, right, till z. So there will be only having 27 nodes. So even for more complex cases, when there are similar structures, when the prefixes are common but only the last characters are changing, so in that case tries also really helps in optimizing the space, right? So yeah, it can definitely help in implementing optimizing the time and space. And so coming to some applications, as we have already discussed, so tries also always help in implementing dictionaries because it helps in searching words, inserting word and removing in order of length of word, right? It helps in pattern matching and spell checker. So if you guys just got idea about tries, you can always implement and solve these problems. And there are some examples also: compressed tries and suffix trees. So if I just give you a brief about both of these, so what a compressed try looks like. So if we consider it, basically compressed try is a more optimized version of tries to save space, right? Inserting some word a b, or let's say just okay. So if we are inserting some word a, b and c, and let's say d, a, if there is an only one word, so what complex try will do is it will store all these into the very first node, all the characters that are common in a one node, right? If there is an another word that is starting with a, b, c, d, e, so it will store it in a next node, right? And if there is an another word that is starting with same a, b, c, d, e, f, then it can have it like f here. So see, if let's say if there are only three words in our try, so the compressed try will look like this. It has it saved space for it, right? So it avoids the overhead of maintaining other pointers for all these A, B, C, D nodes. And if we have definitely, if we have some nodes that starts with A, B, and then there comes some C, not C, actually F, let's say. So then these C and D will separate to some other node, and then F will be separated to other node, and then C and D will have this E and F child, right? So if you guys got an idea, so complex tries will basically compressing as the name suggests, so containing more than one characters in one node, right? And for a suffix tree, if we discuss suffix tries, so suffix tries are nothing but basically they store suffixes. So let's just discuss for it. ABC, if ABC is a word that we need to insert in a suffix try, so what it will do is it will insert all the suffixes of the given string. So similar to prefix, suffixes are the all those substrings starting from last. So ABC is a suffix, right? BC is a suffix and C is a suffix. So it will also insert all those suffixes. So suffix trees will look like these suffix tries. So these are some variations of tries, but like in even competitive programming or interviews, they are rarely asked. Major of the problems are asked in prefix try, right? But definitely we should like note how they works. And other applications are also that are actually we will be implementing in problems that I will also share you guys should solve, right? So one last question, the time is like going. So one last question we will be discussing is that, let me tell you what is the question. So till now you can read this question as well. So what the question says is we are given an array of integers and we have to find the maximum XOR of two numbers and given the constants. So can anyone of you tell me like how we will be implementing solving this problem? We need to find the maximum XOR of two numbers. Anyone who have idea how we can solve it? Okay. So one thing definitely we can do is to iterate over all pairs of the array, and in order of n square we can find all those XOR and we can like return whatever the maximum result for us will be, right? So if we discuss it, so we are given an array of numbers. Let's just say, let's take it from here an example. Okay, so if we are given some numbers like 3 or let's say 5 and 7, right? So we are given three numbers and we need to find XOR, the maximum XOR of two numbers, right? So one thing we can do here is to, like for 3 we will check its XOR with 5 and 7, and for 5 we will check it with 7, and then we can return whatever the maximum XOR will be, right? But this way the time complexity will goes to order of n square, basically checking all those pairs. So if you see the binary representation of each of these, we will be represented by this. 5 will be like, I hope you guys know how we represent numbers in binary form, right? So this way we can represent these numbers in binary form, and then if we see like what could be the maximum XOR, from what numbers it could come from. So as it only contains three binary length of three strings, right? 111 at max. So definitely our XOR will be only containing 3 bits, right? So and to maximize our XOR, we should maximize the last bits, right? And then if possible, we should maximize this number and then this number. Okay. So to maximize this, our goal is to like obviously the rightmost bit should be 1 always. So if this ones, then and also our this bit is maximized, then we should try to maximize it with 1, then it also it with 1, right? So to maximize it, we have also discussed the bit should rightmost bit should be our first priority. So now think like we are given these words in a data structure, right? We are iterating over this array, and we will be keep inserting these number in a data structure. So like insert a word, insert an element we can say, and then if we have some method to calculate the maximum XOR, the maximum ZOR for given element, right? Okay, so for given element, we need to find maximum ZOR out of with all those elements present into it. Okay, how we will do it with try? That is the interesting question here. So if we do it with try, then let me write the example again: 3, 5, and 7. And 1, 5 looks like 0, and 7 looks something like this. So as we have discussed, our first priority is always to basically the rightmost bit should be 1. So consider it as a try, and we are inserting all those elements and their binary representation in try. The rightmost bit should come first. Okay, given in the given problem we have 32 bits, right? But we will consider here only 3 bits for simplicity. And to insert 3, what we will do is we will start from the third most right bit, so that is 0. Okay, we can anyway start from 32 for all those words in the real implementation. So for now, 3 have a 0, we will insert it, right? And then it has a 1 there. Okay, and then again it has a 1, right? For 5, the very first rightmost bit is 1, then it has a 0, then it has a 1. Okay, and for 7 it has a 1, and then it has a 1, right? So in this way we can insert the binary representation starting from the rightmost bit into our try, right? And now if we be our priority, so we will start iterating on the array again for 3. So basically we will now doing is for 3 we need to find maximum ZOR out of all the elements that are in the try, right? So and in this way if we have found, and then for 5 and then for 7, so out of all those maximum results we can find definitely what is a maximum value. So considering now how we will calculate, like what is the maximum ZOR for a given element given we are a try that is represented in binary form, right? Can anyone tell me like how we can calculate? We have a try and the numbers are stored in binary form, so it represents a 3, it represents a 5, it represents a 7, right? Okay, so to maximize the ZOR result we will start from the first element, that is 3. Okay, and as we have discussed, to maximize the ZOR we should maximize the rightmost bit. And writing the ZOR properties here, so for a ZOR if they are same bits then the ZOR is 0, and if they are different then the ZOR is 1, right? You guys must be knowing this formula. So for is 0 first. So now to find the maximum ZOR, we should definitely search for a number that have different bit than 0. Okay, so 3 has its leftmost, oh sorry, rightmost bit as 0. So we must look some number in our try that has rightmost bit as 1. Okay, so we will jump to this other node, other side, right? So we have found. Okay, so now we will check the next bit of 3, that is 1. So again we will check some different bit than 1, that is 0. So we will come to this node, again we will find 1 for the 3, right? And then we will check for another node, that is 0, whether it exists 0 or not, but there is no 0. So we will only have one option to go with one. Okay, so now we have iterated for 5 101, right? 101, and if you take zor, that it is 6. So we have, if you can see that, let me change the color. So if you have seen that here, we have already maximized the rightmost bits, that is 1 1, but we couldn't maximize the leftmost bit, that is 0. So the maximum we can get for 3 is 6, right? So we can update our result to 6. Now for 5, if we search for 5 what is the maximum zor it could have, so its rightmost bit is 1, so it will check for 0 now. Okay, basically the idea is to check different bit, because only then we can get a 1 for that bit for a zor, and only then it could be maximized. So for 5 it will check a 0, then for 0 it will check for a 1, so it will found. Then for 1 again it will check for a 0, but there is no 0, so it will have only one option, that is 1. So it means 5, for 5, that is 101, we have take those nodes that are 0 1 1, that is 3. If we take its zor, so it is 1 1 and 0 again 6, so we still have our answer as same 6, right? And now if we have only one element left, that is 7. For 7 all the bits are 1, so what we will be searching for is zeros at max, at many zeros as we can, but we can only have one zero, that is the rightmost, and then we have only ones there, so we do not have other options. So for 7 we have only 0 1 1, that is 3 to compare. And again the zor will be 100, right? So the zor will be 4. So for 7 the zor came is 4, that is not maximum, so the result is 6. See, we have found the answer, that is 6, by storing all those bits into our try and comparing again using a zor property. So this was really an interesting problem. I would definitely recommend you guys to solve, to basically get those concepts. And I've also attached some resources, and also like we have an a quiz, I think, at the end of session. So definitely you guys can solve these problems. And if you guys need to practice and learn more, then there is a guided path for tries as well, where like we have a very famous problems that are very common, and some notes as well with each topic. So definitely you can try those. These are guided paths that we have like created at coding ninjas. And so these are some basic problems that implement tries that we have discussed today to insert search and starts with these properties in try delete operation. So I will definitely recommend to check it out and like implement those problems. You can read notes there as well, so you can definitely get comfortable with tries, right? And yeah, so other things. So yeah, that's it we have for the session. Thank you everyone for joining the session today. So if you guys have any questions, you can always ask me and connect me on LinkedIn as well. And for even for the current session, if you have any questions, still you can ask.
Thank you, Rahul Bhaiya, for
So any,
coming to this event and helping students.
thank you Hans, and thank you the DSA Carnival for inviting me. Okay, so
Okay, Bhaiya.
okay, so I think thank you everyone. Bye bye.
Now I will announce winners of yesterday's quiz. And winner of yesterday's quiz is Arvind from RVCE. Also, today's quiz will link will be shared in description box and comment section. So participate in the quiz and win T-shirts. And do not forget to and practice question. Their link will be also provided in the description box. Thank you for being a patient listener.